This is homework 3, starting with problem 101. Write an equation for each situation below showing that the area as a product is equal to the area as a sum. I'm going to be solving these two. Start with B. Multiply to fill in the squares. 2m squared times 3m. This is the trickiest one. 2 times 3 is 6, and m squared times m is going to be m to the power 3. Okay, and then down here we have 5 times 2m to the power 2. That's 10m to the power 2. You multiply 2 times 5 to get 10. Right here we have negative 4m and 3m. Negative 4m times 3m is negative 4 times 3 is negative 12. M times m is m to the power 2. Right here we have negative 4m times 5. Negative 4m times 5, so that's negative 20. Negative 1 times 3m. 3 times negative 1 is just negative 3. So that's negative 3m. And then lastly, 5 times negative 1 is negative 5. Okay, we need to write our area as a product. So that's 3m plus 5 times 2m to the power 2 minus 4m minus 1. So length times width. That's our area as product. And that should equal area as a sum. So that's going to be 6m to the power 3. Combined like terms, we have m squareds, negative 12 and 10. Negative 12 and 10. So that makes negative 2m squared. I did that in my head, but what I did was I subtracted. And if you subtract 10 minus 12, it's negative 2m to the power 2. Looks like I made a little typo here. We've got 5 times negative 4m is negative 20m for a total of negative 23m. If you combine like terms, negative 20 and negative 3 is negative 23. Okay, so that's our answer. Area as a product is equal to area as sum. Alright, for part D, they already gave us area as product. We just have to write it as a sum. This one is DYOB. Draw your own box. We've got 3 and minus 5y on one side. And then the other side of the box we have 2 plus y. And there's 2 terms here. This is a binomial. 2 terms here, that's a binomial. So this box is going to be 2 by 2. Alright, so 3 times 2 makes 6. 2 times negative 5y is negative 10y. 3 times y is 3y. And negative 5y times y is negative 5y squared. Y times y is y to the power 2. Let's combine like terms. Our answer is going to be negative 5y squared. If we combine these together, we get negative 7y. That's because 3 minus 10 is equal to negative 7. So 3y minus 10y is negative 7y. And we've got a positive 6. We're going to add 6. Alright, and that's our area as sum. And here's our area as product. 3-102. Calculate each of the following products by drawing and labeling an area model or by using the distributive property. I'm going to do that for B. Part B. Distribute the 9x. So we have 9x times negative 4, and then there's a plus sign. 9x times 10y. Okay, so 9 times negative 4, That's negative 36x plus 9 times 10 is 90, and then x times y, xy, basically. So there's the area as the product, and here is the area as sum. 3-103. On graph paper, graph triangle ABC if A has coordinates negative 4, 3, B has coordinates negative 6, 1, and C has coordinates negative 8, 5. Okay, in order to rotate this, you're going to want to use trace paper. Alright, and it's 90 degrees clockwise. So use your trace paper, and you're going to find out that A prime is here. Again, you just use your trace paper. B prime is there. And there's C prime. So you can see that it rotated from here to here. And it's clockwise, same way the clock goes. And I use prime notation. A prime, B prime, C prime. What are the coordinates of A prime right here? That's going to be 3, 4. Okay, so you're going to apply this function next to translate A prime, B prime, C prime. What are the new coordinates of C double prime? So I'll do A prime, if you like. You can finish this one. X plus 5, if you think about the x-axis, positive means towards the right, 5. And then y plus 1, if you think about the y-axis, plus means up. Positive direction is up. So for example A, if we take A and go right 5 and up 1, we can find our new A prime. Alternatively, if we take these coordinates and then we write the image, you can get the image by adding 5 to x. So 3 plus 5 is 8, comma, and then you take the y coordinate and you add 1 to it. So 4 gets added by 1 and it's 5. So that's alternate solution. You can see that it matches. This is 8, 5, and then it matches what I found here. So see if you can figure out where does C go? What's C double prime? 3-105. While David was solving this equation, 100x plus 300 equals 500, he wondered if he could first change the equation to x plus 3 equals 5. What do you think? Can you do that? Solve both equations and verify that they have the same solution. Let's try it. On this one, let's solve for x. Solve for x, make x alone. So step 1 would be take away 300 from both sides. To make a zero pair, that's going to cancel. We have 100x equals 500 minus 300 is 200. Then we divide both sides by 100. Divide both sides by 100. 100 goes into 200 2 times. So the answer is x equals 2. Now, on the other equation, it's simpler. All you need to do is take away 3 from each side, and then x is already alone. X equals 2. So, they have the same solution. You can answer this one. What could you do to the equation 100x plus 300 equals 500 in order to change it to x plus 3 equals 5? Think about dividing. What could you divide this by to turn it into that? 3-106. This problem is a checkpoint for operations with rational numbers. it will be referred to as checkpoint 3. Compute each of the following problems with fractions. Let's start with A. I'll do one of the division ones. And let's go B. Alright, so when you add fractions, they need to have a common denominator, but they don't. So what you can do is take the fraction on the left and you multiply the top and bottom by 8. For the fraction on the right, you can multiply the top and bottom by 3. Now how did I figure that out? Well, 3 times 8 is 24. And on the top we have negative 2 times 8, negative 16, plus, on the right we have on the bottom 8 times 3, that's 24, and on the top negative 1 times 3, negative 3. So you can see that I use this trick to make the denominators the same. You basically multiply 3 onto this side, you take 8 and you multiply that onto the left hand side. Alright, so now that they have a common denominator, this is going to equal, I can put them into a single fraction, negative 16 plus negative 3, and it's all over 24. Answer. Part B, 3.5 minus negative 1 1/3. So that is 3.5 plus 1 1/3. Alright, so you can solve this in many ways. I like converting them to an improper fraction. 3 times 2 is 6. Add 1, that's 7. 7 over 2 plus 1 times 3 is 3. Add the 1, that makes 4, so it's 4 over 3. 3, the original denominator. And then here, 2, the original denominator. Using the same trick as over here, I'll take the fraction on the left and multiply by 3 over 3. And the fraction on the right, I'll multiply by 2 over 2. Okay, so 7 times 3, that's 21 over 3 times 2 is 6. It's 21 over 6 plus. On the right, we have 4 times 2, that's 8. 8 over 3 times 2 is 6. So they have a common denominator. That's the trick. You multiply 3 on the left, and then you take 2, you multiply that on the right. Now we can combine them into a single fraction. 21 plus 8 is 29. Okay, if you loved mixed fractions, this is going to be 4. 6 goes into 29 4 times, and it has a remainder of 5. Either one is fine. Part D. When you divide two fractions, keep the first one, change the sign, flip. Keep the first one, change division to multiplication, flip. Keep, change, flip. Nice thing about multiplying fractions is you just multiply straight across. Negative 2 times 4 is negative 8 over 3 times 1 is 3, and we're done. You can also turn this into a mixed fraction. 3 goes into 8 2 times, and then there's going to be a remainder of 2. This is a negative number, so the outcome should still be negative. So negative 8/3 or negative 2 2/3 is your answer. You can check your answers by referring to the checkpoint 3 materials. That's in the textbook. On to 3-114. David wants to solve this equation, 4,000x minus 8,000 equals 16,000. What easier equation could he solve instead that would give him the same solutions? In other words, what equivalent equation has easier numbers to work with? Well, this was discussed in class. You are allowed to just divide everything by 1,000. Let's see what happens. 1,000 goes into 4,000 4 times, so that's going to be 4x minus 1,000 goes into 8,000 8 times. So this 8,000 over 1,000 just turns into 8 and is equal to 1,000 goes into 16,000 16 times. All right, justify that the equation in part A is equivalent to 4000x minus 8000 equals 16,000 by showing that they have the same solution. So let's solve this one. Isolate x. You can start by adding 8,000 to each side. So that's going to leave you with 4000x equals 16 plus 8 is 24. So that's 24,000. All right. And then to get x alone, you divide by the number in front of x. So you divide each side by 4,000. That's the number in front of x. Okay, and then 4 goes into 24 6 times. So 4,000 goes into 24,000, still 6 times. 4,000, 8,000, 12,000, 16,000, and so on. X equals 6. If we solve this guy over here, let's see if we get the same solution. Okay, so isolate x. Let's first add 8 to each side, and we get 4x equals 24. And then we divide both sides by the number in front of x, which is just 4 this time. So x is equal to 6. Check. Try part C. Tuesday homework 3-115. Examine the rectangle at the right. If the perimeter is 120, which equation below represents this fact? Once you have selected the appropriate equation, solve for x. Okay, so 6x minus 1 is the length of these two sides. They're the same sides because rectangles have opposite sides equal. So that's also 6x minus 1. And similarly, on the right side, this is 2x plus 5. So this side is also 2x plus 5. The opposite sides are equal. Now, perimeter is what you get if you just go around in a circle and add everything up. So the perimeter is equal to 6x minus 1 plus 2x plus 5 plus 6x minus 1 again, and then plus 2x plus 5 again. Now, that should equal 120, because this perimeter is supposed to equal 120. Okay, so as you can see, none of them really match, but if you group these 6x minus 1s together like that, notice that there's 2 of them. So if I want, I could rewrite this as 2 times 6x minus 1, because there's 2 of them. Alright, and also for the 2x plus 5s, if I group them together, there's 2 of them. So if I want, I could say 2 times 2x plus 5, because there's 2 of those terms. Alright, now they're still being added together, so I still need to put a plus sign here. And they're still an equal 120. And the answer is C. Okay, you still need to solve for x, so I'll let you do that. You can distribute the 2's. 12x minus 2 plus 4x plus 10 equals 120, and then solve for x. 3-116. Which of the following expressions are equivalent to 12x to the power 6? I'll do C. I'll do A. Okay, this raised to the power 1/2. This is the same thing as, well, let's just solve this. So if you do raised to the power 1/2, this is 144 to the power 1/2, and then we have x to the power 12 raised to the power 1/2. You know, when you have a power to a power, you multiply. So x to the power 12 raised to the power 1/2, that is 12 times a half. And that's going to be x to the power 6. So I'm not sure why they put this in the homework. You get to cover this in integrated 2. If you have a number raised to the power 1/2, you can rewrite it as square root of that number. So we'll rewrite this as square root of 144. And the square root of 144 is 12. So 12x to the power 6. Don't worry about this 1/2 square root thing. That's integrated math 2. Alright, part A. 3 times 2x to the power 3 squared. A couple ways to approach this. I'm going to do the shortcut. So it's 3 times 2 to the power 2, and we have x to the power 3 raised to the power 2. So this is 3 times 2 to the power 2. 2 squared is 4. And then x to the power 3 raised to the power 2, power to a power, multiply. So we've got 12, 3 times 4, that's 12, x to the power 6. That one is also. Alright, so I'll let you figure out the rest of them, B and D. 3, 117. Multiply the expressions, show your work. I'll do C, and I will also do B. This one I'll do using FOIL, so I'm going to multiply those two terms together first. Outside, inside, last. 3y times negative x. Positive times negative, so negative, and then 3y times x is just 3yx. I think that should be blue. Okay, and then we have the green one, 3y times y, and 3y times y is 3y to the power 2. Okay, and then we have negative 8 times negative x. A negative times a negative is positive. 8 times x is 8x. Plus negative 8 times y. So we have a negative times a positive, so it's going to be a negative. And then 8 times y, that's just 8y, negative 8y. Alright, so you can search through these, but none of them are like terms. So this is our answer. I'm going to rewrite this as just minus. When you add a negative number, you can rewrite it with just subtraction. Okay, that was FOIL, but we can also use the area model method. This is also known as the box method. You can also use FOIL on this one too. It's whatever you prefer. I just want to show you both. Okay, so this first little expression in parentheses has 2 terms, and then this one also has 2 terms. So we need to draw a box that's 2 by 2. On the top of the box, I can put negative 2x squared minus 4x. That's my first side. Then on this side of the box, I've got 3x plus 4. That's 3x plus 4. And it's like a multiplication grid. So we fill it in by multiplying. Negative 2x squared times 3x. Negative 2 times 3 is negative 6. And then x times x to the power 2. That's x to the power 3. 4 times negative 2x squared. That is negative 8x squared. Negative 4x times 3x. 3 times negative 4. Negative 12. And x times x. X squared. Bottom right, we have negative 4x times 4. Negative 4x times 4, that's negative 16x. And let's fill in our answer. So these ones are like terms. The x squareds. So this is equal to negative 6x to the power 3 minus 20x squared minus 16x. 12 and 8. 12 and 8 make 20. So negative 12 and negative 8 make negative 20. 3-118. Find the result when each indicated transformation is performed. Let's reflect A across line L, and let us rotate C 180 degrees about point Q. Alright, so you want to use trace paper, as always. It's a lot easier if you just use trace paper. I'm just making a mirror image here, that's the key. If you don't want to do it without trace paper, I'll call that A prime. So reflections are mirror image. Let's try C. Okay, 180 degrees, that means this point is going to be down here. And again, just use trace paper, it's so much easier. This point is going to be over there. Alright. This point is going to be right here. Okay, so we have this side. So use trace paper. I'm just counting, using the counting method. So Q, if I go over 1, 2, 3, 4, 5, 6, 7, and up 2, I'm at this point. So this way I should go 1, 2, 3, 4, 5, 6, 7, and down 2. I'm at the same point. And if I come over 2 this way, I'm here. So if I come over 2 this way, I'm here. There's that side. This side right here. There's that side. And then I'm just making a mirror image now. So this is like 1, 2, 3, 4, 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3. There's that, and then we connect the dots. Alright, so this is C prime, I'll call it C prime. And it's a rotation, spun around the point Q. Use trace paper, it's a whole lot easier. 3-127. Solve the equations by changing each equation to a simpler equivalent equation. Check your solutions. Okay, so for A, since everything's in the thousands, I'll let you solve that. Why don't we practice some with fractions? So, part B. Circle the denominators, and then let's find the LCD of 3 and 7. So that's the least common denominator. So that's 3, 6, 9, 12, 15, 18, 21, and so on. 7 goes 7, 14, 21, 28, and so on. So the first number that's the same I can see is 21. The LCD is 21. Alright, now I'm going to multiply each term by the LCD. Okay, so for my first fraction, 21 times negative 2x is negative 42x over 3 minus. Second fraction, 21 times x, that's an easy one, which is 21x, and that's over 7 equals 21 times 17. I think I'm going to use a calculator for that one. So that's 357. Alright. 3 goes into 42 how many times? If you don't know, just divide. 3 goes into 4 one time. 1 times 3 is 3. And then 4 minus 3 is 1. Carry down the 2. 3 goes into 12 4 times. 4 times 3 is 12. Remainder 0. So that's 14. Alright, so I can transform this into negative 14x minus 7 goes into 21 3 times. So that's minus 3x equals 357. Solve for x. Negative 14x minus 3x, that's negative 17x equals 357. Divide both sides by the number in front of x. don't forget the negative sign because it's negative 17. The coefficient of x is negative 17. So 357 divided by 17, negative 17, is negative 21. All right. Now it says to check your solutions. You can check it if you like. There it is. There's the answer. All right, let's do another one. For D, we have 3 fractions. Let's find the LCD. 10, 5, and 2. 10, 20, 30, dot, dot, 5, 10, 15, 20, dot, dot, dot. 2 I think is going to hit 10. 2, 4, 6, 8, 10. 12, dot, dot, dot. So the first number they have in common, the least common denominator, is 10. So what does that tell us? That tells us we need to take each fraction and multiply it by 10. Fraction busters. So 10 times 3 over 10 plus 10 times 2x over 5 equals 10 times a half. Alright, 10 times 3 is 30. So this is 30 over 10 plus 10 times 2x. It's 20x over 5 equals 10 times 1 is 10. It's 10 over 2. Okay, 30 over 10 is 3 plus 5 goes into 20 4 times. So that's 3 plus 4x equals 10 divided by 2 is 5. Isolate x, so let's take away 3 on each side, and we get 4x equals 2. Divide both sides by the number in front of x. So x equals 2 over 4. But you better not leave it like that. Best simplify. 2 over 4 is a half. Right, 2 over 4. If you divide the top and bottom by 2, that turns into a half. Alright, 3-129. Plot ABC on graph paper. If A is 6, 3, B is 2, 1, and C is 5, 7. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. There we go. Alright, let's do part A. Part A says, ABC is rotated about the origin 180 degrees to become A prime, B prime, C prime. Name the coordinates of A prime, B prime, and C prime. Use your trace paper. These are so much easier if you just use trace paper. And unfortunately, I can't really demonstrate that because I'm writing onto my computer. But if you use trace paper, it's so fast. You're rotating around the origin, 180 degrees, so it should be down here. That's B prime. A prime is going to be there, and C prime so that's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So I'm doing the counting method, but just use your trace paper and you can do this a lot faster. And easier too. So A prime is going to be -6, -3. B prime is going to be -2, -1. And then C prime is going to be -5, -7. So what you notice is it's the same coordinates, except everything is negative. It switches signs. Okay, part B. This time, triangle ABC is rotated 180 degrees about the point C to form A double prime, B double prime, C double prime. So triangle ABC is this one. It's the original one. And we're rotating it about point C. So draw your plus sign there. Let's go 180 degrees. there's A double prime. And then B is going to be somewhere up here. 180 degrees means goes kind of opposite to C, so that's 6, 3. So I go 1, 2, 3, and then 4, 5, 6. And there's my B double prime. And then C, since we're rotating it about this point, C double prime stays in the same location. Alright, so we're supposed to name the coordinates of B prime. Let's see what they are. Again, use that trace paper, and this is so much easier, and it's very fast. So B is 1, 2, 3, 4, 5, 6, 7, 8. B double prime is 8, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright, C, again, use the trace paper. It should be pretty easy. Just spin it. Don't forget to draw the plus sign wherever you spin it around. Wednesday, 3-130. Jessica has 3 fewer candies than twice the number Dante has. If Dante has D candies, write an expression to represent how many candies Jessica has. Okay, so Jessica has 3 fewer, minus 3, than twice the number Dante has. Dante has D, so twice the number is 2 times D. So Jessica has 2 times D, twice the number Dante has, but then 3 fewer than that, so minus 3. A nice way to write that is 2D minus 3. So that should be 19. 2D minus 3 should be 19. I'll let you solve. Find out how many candies Dante has. Solve for D. Dante has D candies. Make D alone. 131. Determine the value of x that will make each equation below true. These ones, make sure they have the same base on each side. 2 to the power 3 equals 2 to the power x. They have the same base. So you can cross them off and set the exponents equal to each other. That was an easy one. X equals 3. Alright, how about D? These have this, actually let's do B. X to the power 3 equals 5 to the power 3. What number raised to the power 3 equals 5 to the power 3? It's just 5, right? It has to be 5, because then they'll be equal. So if we let x become 5, that would make this equation true. Same process for C and D. Just cross off the base, set the exponents equal to each other. 3-136. Solve each equation first by rewriting the expressions in each part with the same base. Refer to problem 3-132 from class if you need a reminder. Let's look at A. A, we have 8 to the power x equals 2 to the power 6. Okay, 8 is big. 8 is bigger, right? And we need to shrink the bigger base. So we need to shrink 8 so that it's 2 to the power something. 2 to the power 2 is equal to, so 2 to the power 1 is 2. 2 squared, or 2 to the power 2 is 4. 2 to the power 3 is 8. So that's just 2 times 2 times 2. 2 times 2 times 2 is 2 to the power 3. So this is 2 to the power 3 raised to the power x. 2 to the power 3 raised to the power x. Power to a power, you multiply. So this is 2 to the power 3x equals 2 to the power 6. So basically 8 becomes 2 to the power 3. So now we have 2 to the power 3x equals 2 to the power 6, and you cross off the bases. They are now the same. That was the whole point of this. Make the bases the same. So cross them off. Now that they're the same, we have 3x equals sine 6. 3x equals sine 6. Divide both sides by 3, and you've got yourself the answer, x equals 2. Do the same for B. C is tricky. How do we make these bases the same? Well, 1/2, fun fact, is 2 to the power negative 1. Negative exponent. Flip. And the exponent becomes positive. So I can rewrite this as 4 to the power 2x equals 2 to the power negative 1 raised to the power x plus 5. Alright, Now if I put little parentheses around these, I have to, power to a power, 2 to the power negative 1, raised to the power negative 5, I have to multiply. So I have 4 to the power 2x equals 2 to the power negative 1 times x plus 5. Let's distribute that negative 1. So that's 2 to the power negative x, negative 1x, and then negative 1 times 5 is just, it's not going to be plus negative 5 here. It's negative 1x plus negative 5. So let me just write this as negative 1x minus 5. Not done because their bases still aren't the same. But 4 is 2 squared. 4 is 2 to the power 2. So we shrink the bigger base. Shrink it down now. This is 2 to the power 2, and that's raised to the power 2x. That's equal to 2 to the power negative 1x minus 5. So 4 became 2 to the power 2. Alright, and a power to a power, we multiply. That's 2 to the power 4x equals 2 to the power negative 1x minus 5. Bases match. So let's cross off the 2. And we've got ourselves a math problem here. This is 4x equals negative 1x minus 5. So we have an x on both sides of the equal sign. So you pick the smaller x, which is the negative 1, x, and add 1x to each side. Make it cancel. So I've got 5x equals negative 5, and last step is divide by the coefficient of x. Divide by the coefficient of x. The number in front of x is 5, so divide both sides by 5, and x equals negative 1. Any number divided by itself is 1, and a negative divided by a positive is negative. So that was a pretty difficult one. I'm going to put 3 stars on that. That's challenging. But just go step by step. You guys can do this stuff. On to 3-138. On graph paper, draw this triangle with the vertices, negative 3, 3, 4, 3, 2, negative 2. What is the area of this triangle? I'm going to kind of think about it like this. The area is 1/2 times base times height. So this triangle is upside down. This is actually the base. And then the height of the triangle, that's all it is. Let's see. So the base is 1, 2, 3, 4, 5, 6, 7. And then the height of the triangle, coming through the middle, is 1, 2, 3, 4, 5. So the area is 1/2 times the base, which is 7, times the height, which is 5. So this is just 1/2 times 35. Get that calculator out if you need to. That's 17.5. Don't forget to square your units. This is 17.5 units squared. Now I'll let you do B. I don't think this one's too bad. Translate the triangle 3 units left and 2 units up. What are the new coordinates? Make sure you write them. 3 left, 2 up. Do it for all 3. 3-140. Okay, again, there's been many of these. Use your dang trace paper. It's so much easier. And it's fast, and it's fairly accurate. So I'm going to do this without trace paper, but you should be using trace paper. I would show you with trace paper, but I can't on my computer. So part D, and we'll do C. D, rotate figure D 180 degrees about point Q. This is going to come around this way. That point's going to move down there. Okay. And then this point is going to move here. And then this point is going to move 1, 2, 3, 4, 1. So we go down 1, 2, 3, 4, 1. Okay, and then it's 1, 2, 3, 4. There it is, D prime. Now if you had trace paper, you trace this figure, put a dot at each corner, draw a plus sign at the Q, and then you just spin it around until you get to this shape, 180 degrees. Alright, reflect figure C across line M. So now if you have trace paper, you basically just trace this on your trace paper, and then you flip it upside down across this line. Without trace paper, it's a little more difficult. This dot comes here. This dot goes there. Okay. Just trying my best to get this thing. Mirror image is what I'm going for. And I think I went too far. There we go. So this is what it's going to look like when you reflect it across line M. Mirror image. Solve each of the following equations. 141. Explain or justify each of your steps. Be sure to show your work carefully and check your answers. Let's do C and B. B. Solved by rewriting. Distribute the 6 on the left side. Distribute the negative sign on the right side. 6 times 2x is 12x minus. 6 times 5 is 30. Negative x plus negative 4. We've got an x on each side, so pick the smaller one. Make it cancel by adding x. Adding x to each side. Negative x plus x, 0. 12x plus x, 13x minus 30 equals negative 4. Isolate x, make x alone by adding 30 to each side. So we've got 13x equals, be careful, use a calculator if you have to. This is 26. And then divide both sides by 13. X equals 2. So we distributed. We added x. Then we add 30. And then we divide by 13. We're supposed to justify. Okay, part C. Solve by rewriting. Distribute the negative sign, 2 minus y plus negative 2. So it becomes negative y and negative 2, and that's equal to 3y. I do have to combine like terms here. These are like terms. I have a 2 and I have a negative 2. A 2 and a negative 2. 2 and negative 2. That's 0. 2 and negative 2 is 0. So all I have is negative y equals 3y. I have a y on each side, so pick the smaller y and make it cancel. Make it cancel by adding it. Add y to each side. So this is 0 equals 4y. Divide both sides by the number in front of y, the coefficient of y. Divide by 4, divide by 4. This is y equals 0. So what do? We distribute. And then we add y on each side. Divide by 4. Oh, and after we distributed, we combine like terms. We had 2 plus negative 2 equals 0. They canceled. So this one is, a lot of people write no solution on this one, but that's false. This one has a solution, it's 0. So make sure you circle your answer, 0. If you think about it, 2 minus 0 plus 2, that's 2 minus 2, which is just 0. On the right-hand side, 3 times 0 is just 0. So 0 equals 0. Check. So the number that makes this work is 0.